Okay, good day everyone. So we are here for your next topic for hydraulics, which is water flow in pipe. So today we will have a video recording lecture. So we will start by defining what is the meaning of or what is the definition of your pipes. So according to the definition, pipes daw is a tubular section or hollow cylinder that is usually but not necessarily a circular section. So it is not necessary that yung magiging pipes natin is within a circular shape or circle shape siya. So it is not necessary na ganun yung magiging itsura ng ating magiging pipes. So it is used to convey substance which can flow. Okay? So, lahat ng nangyayari sa atin or I mean all around us is pipes no na nagki-carry ng liquids from one place to another. So, specifically, the best example for our pipes is yung mga sewerages natin. Like for example, sa sink no yung mga pinanghugasan natin, yung pinagpupuntahan ng mga pinanghuhugasan natin ng tubig no, yun yung mga pipes natin. Example of your pipes or your sewerage pipes na kino-convey mismo yung wastewater papunta sa ating mga canals. So that is a perfect example for your. So pipes is really a discussion of fluid mechanics or also called as fluid dynamics, no, because it is to study how fluids will behave while in motion. So when there is a velocity, no, ibig sabihin there is a motion sa ating fluids. So sa fluids natin, no, or yung sa fluid mechanics ninyo, you have two different types of flow, no? Kung naaalala ninyo, you have your steady flow, sulat natin dito. So you have your steady flow. You have your steady flow, which is your water conveys like this or move like this. And you have your turbulent flow, no? Where your, hirapan tayo, maging ganyan siya. Okay, ganyan. Basta, ganyan yung graph natin for your turbulent flow. So, pag sinabi nating steady flow, yung fluid natin maintains a constant velocity at a given type of depth. Depth. So, ibig sabihin, kahit gaano kalalim yung ating magiging liquid surface natin no papunta sa taas, so ang kanyang velocity would still remain constant. Parang calm lang yung flow niya ba, steady lang yung magiging flow ng ating tubig. So pag sinabi naman natin turbulent flow, so fluid changes in speed, in direction all throughout sa pipe. So ato pa mag nagkandayago ang tubig, it's because at a different type or at different depth, yung tubig natin is iba-iba yung nagiging speed niya, iba-iba yung nagiging velocity, or iba-iba yung pagiging flow in motion niya. Parang samok ba, no? Hindi sila organized or hindi uniform yung kanilang movement. So, ganun yung ating two types of your flows. So, what tends that flows? Ano ba yung nagagawa ng flows na yun, no? Yung pagkiskis natin sa fluid and sa pipe natin mismo. So, meron tayong tinatawag na head loss. So, head loss refers to the measurement of energy dissipated in a system due to friction. So, ibig sabihin daw, when there is a friction, merong energy na nawawala. Ano ba yung ibig sabihin ng friction? Di ba ang friction is ang pagkiskis o ang pagkuskus ng two different substance. So, pag pipes ang pinag-uusapan natin, there is a friction when the fluid touches the pipe. Okay, kasi 'di ba, ang we all know that your when there is a velocity or when there is a movement, ang ating substance or ating fluid inside is gumagalaw. So ibig sabihin yung at the top, no, kinikis-kis ng substance natin yung pipe natin. So kunyari ito yung magiging fluid, ito yung magiging tubig, ito yung tubig, no. So as it moves, as it has a motion, no, kinikis-kis ng kinikis-kis nga yung ating pipe. So when there is pagkiskis or also called as a friction, ibig sabihin may nawawala tayong energy. Okay? So what causes a head loss? So According to hydraulics, no, it is the caused by the velocity of the flowing water of the roughness of the pipe. So, ang ating pipe is hindi talaga siya ganun ka-smooth. Hindi siya smooth structure. Ibig sabihin, meron tayong roughness, kaya sumasadsad na sumasadsad. Even if smooth ang ating magiging pipe, when there is a friction, there is energy dissipation or the energy can be dissipated, no, when there is a friction. So, sa head loss natin, meron tayong kino-consider na major losses and you have your minor losses. Your major losses are due to friction that can be calculated using the formulas that I will be given or I will be giving you later. No? Papakilala ko yung mga major uh, head losses natin. So you have also your minor head losses. No, it is due to the suddenly enlargement of the pipe. Ano ba yung ibig sabihin ng suddenly enlargement of the pipe? For example, you have your siyang drawing. Wait lang ha. So for example, you have your first pipe as maliit, tapos biglang lumaki yung pipe, no? Ibig sabihin from this your V in, velocity in, tapos papasok kayo ng mas malaki, di ba mas magwa-wide yung area ng papasukan ng ating fluid. So, that scenario daw can be considered as a minor head loss only, no? Due to the enlargement of the pipe or due to the bending of the pipe, no? So, due to the entry of the pipe, due to obstruction of the pipe. Di ba, we all know na we have different types of pipe. Meron tayong yung pipe nga, yung sinabi ko kanina, na bigla lang siyang lumalaki. And yung meron tayong elbow pipe or yung parang macaroni na pipe. So, if steady yung magiging flow ninyo, tapos bigla lang siyang magbe-bend, no? So, this can be considered as a minor head loss only. So, you have here also a definition for your discharge. So, the measurement of fluid passing a section of a stream in unit time. So, you have a formula for your discharge that would be Q is equals. So you have a discharge here, no, that the meaning is the amount of fluid passing a section of a stream is unit time. Q is equals to AV. I-repeat ko lang ha, kasi parang nag-glitch yung ating Zoom. Nawawala yung connection pa rin hanggang ngayon. So again, pag head loss, you have major head loss and you have your minor head loss. Yung major head loss, that would be a reference natin yung magiging formulas na ito-talk natin mamaya. And then for your minor head losses, that would be a sudden change in enlargement of a pipe or sudden pipe bending, no? Yung like for example, yung mga macaroni or your elbow pipes natin. Yung mga straight na pipe tapos bigla lang magbe-bend, that, no? So the head loss for that would be a minor head loss only. So you have here your discharge, the amount of fluid passing a section of a stream in a unit time. So you have a formula that it is Q is equals to AV, where your Q is discharge or also known as your volume flow rate, and your area, that will be the cross-sectional area of flow in meters per second or feet per second, and your V or your velocity, that would be in flow meters per second. So what would be the unit for your tawag niyan, for your discharge, that would be meter squared multiplied by meter per second. Therefore, you will be having cubic meters per second. Okay? Volume over time. Okay? So, let us try to explain more ano ba yung ibig sabihin ng ating discharge. Draw muna tayo. For example, it is a pipe. Okay, bear with it na lang. It is a pipe. So in a system of a pipes or any flowing fluids, you have the same volume traveling to each point or in the system, and that is your Q, or that would be called as your discharge. Yan yung lumalabas na fluid natin. Okay? So the volume, it is also called the volume flow rate as I mentioned earlier. So the application of that means that as you are moving through the pipe with a larger cross-sectional area, the fluid will be traveling slowly. So, ibig sabihin, if you have a larger cross-sectional area, yung fluid niyo is mabagal lang yung kanyang, or yung movement niya would be slowly lang. Okay, or mahina lang. Smaller, no?
or magiging mahina lang niya. Tama. So at any point in the fluid system, the discharge is going to be equal to the area is equal to the area times the velocity. But then again, if you're in a smaller area, the velocity will be greater and larger series of pipe will be moving slowly. So ano bang perfect example sa sinabi ko kanina? So sabi niya sa definition ng discharge, no, kapag malaki daw yung magiging area ng inyong pipe, ang flow daw ng water ninyo would be slowly. So once it gets into a smaller pipe, bumibilis daw yung takbo ng tubig natin. So the perfect example for this one is yung hose natin. 'Di ba pag freely lang ninyo ipaagas ang tubig sa inyong hose, medyo slowly nga siya. But then again, pag pinihit mo yung tip or nilagyan mo man lang ng nozzle yung tip ng hose ninyo, pinapaliit nyo cross-sectional o yung opening of your cross-sectional area of your hose, 'di ba mas musirit ang tubig? 'Yun. Okay? So ibig sabihin mas bumibilis yung velocity ng tubig natin when the area or when the cross-sectional area of the pipe is maliit. Okay? But still, even if it is a larger or smaller ano yan, pipe, no, they are still pushing the same amount of uh, fluid, no? Kahit na dito sa start natin, pag ito sa large amount or sa bigger cross-sectional area, kung ano yung pinapasok mo na fluid dito, even if liliit yung cross-sectional area of your second pipe, that would be the same fluid lang pa rin na nilalabas niya. Okay, nevertheless, the formula that we are going to use, that would be Q is equals to AV. Okay, so let us try to have a example. I mean, your formulas for your major head losses. So again, ano ba yung head loss? It is the energy dissipated because of the friction, because of the pagkiskis ng ating fluid at ng ating pipes. Okay? So for Darcy waste back, Darcy waste back, you have a formula here for your hydro, ano tayo? Hydraulic head losses is that you have your head loss is equals to FLV squared divided by D2G. And you have another formula for that. If yung discharge naman ang given, you have 0.0826 FLQ squared divided by 5. And you have another. So yung itong ating Darcy waste back, tama ba? Darcy waste back is usually ginagamit ito sa Europe. Okay? So, ang Mannings, you have a formula of 6.35 n squared LV squared D raised to 4 thirds and 10.29 n squared LQ squared divided by 16 divided by 3. So, your Mannings is ginagamit natin sa USA. No? Mostly sa USA natin siya ginagamit. So, you have here your velocity or your mean velocity. You can get that formula or you can get the value using your 1 over n or 2/3 as 1/2. Sige lang, pag-uusapan natin yung mga variables in a while. Papakita ko lang muna lahat ng formula. And you have another formula or head formula for your head loss that would be, I know, I think si Mannings is Australia. Sorry for that. Ulitin natin. Si Darcy Weisbach, that would be in Europe. Si Mannings, that would be in Australia. And then si Hazen Williams, that would be USA. That would be USA. So you have your head loss formula for your Hughes and Williams. So you can get your velocity through this formula and also for your discharge. No? So it is safe to memorize din ito mga head losses natin. So napakadali lang ng topic natin, no? Sobrang dali lang. Ano lang yung magiging problema ninyo? That would be the memorization of your or yung pag-memorize lang ng mga formulas natin. But I believe, no, sobrang dali lang yan para sa inyo. So for your circular pipes and non-circular pipes, you can get your R or your D that it would be equals to 4R or that will be your R is equals to A times P. So let us have some of the definitions para mas makilala natin. So you have your HF here, also known as your head loss in pipes. It is the energy dissipated due to friction. Your F sa Darcy Weisbach, that would be the coefficient of friction. Okay, your L, that will be the length of the pipe. Your V, that will be the velocity of the fluid. And G, that would be the gravitational or that would be the gravity. Your Q, that would be the discharge of the fluid. Yan yung diniscuss natin kanina. Your D, that would be the diameter of the pipe. Your N in Manning's called your roughness coefficient. So your F in Darcy-Weisbach, that is called as your coefficient of friction. Your N for Mannings, that is called as the roughness coefficient. Okay? So you have here your R as your hydraulic radius. So yung hydraulic radius natin, that would be the area over the wetted perimeter. Area divided by the wetted perimeter. So pag sinabi nating area, that will be the area of your pipe. Okay? Pag sinabi natin wetted perimeter, no, for example, you have a uh, sabihin na natin magiging square yung magiging pipe ninyo. Ang tubig ninyo is hanggang dito lang. So ang perimeter, and this is the total of 2, this is 3, and this is 5. Ano na ba yung wetted perimeter natin? Di ba ito lang yung part na nababasa? Okay, yan lang yung part na nababasa. Therefore, your perimeter, that would be 3 plus 5 plus 3. Yung 3 ito is ito. Hindi natin isasali yung height above, no? Yung 2, because hindi naman siya nababasa. Again, your P, that would be the wetted perimeter of your structure. Your A, that would be the area of the pipe. And you have another formula, that would be the slope of the hydraulic gradient. So, pag sinabi nating slope, no, it is the head loss of per unit length of the pipe. That is why you have your head loss divided by length, or that would be your hydraulic slope, hydraulic gradient slope. Yes, that would be hydraulic gradient slope. Okay? So you have also, no, as I mentioned kanina sa inyong discharge, you have a head loss in nozzle. Kasi 'di ba, yung sinabi ko, kung gusto mong palakasin yung discharge ng tubig mo sa hose mo, pihitin mo yung hose or lagyan mo ng nozzle. But take note that there is also a friction between the water and the nozzle. Kasi dumadaan yung tubig ay kumikis-kis pa rin yung tubig sa nozzle. Tama? So you have a formula, or for your head loss in nozzle, you have your V squared over 2g times 1cv squared minus 1. So you have here your HP, or your horsepower. That would be discharge times unit weight density times E, excuse me, divided by 746. No? Your E, that would be your energy. That would be V squared over 2g. Where your CV, that would be the coefficient of velocity. Parang kung uh, sa Darcy waste ba kanina, meron tayong F as coefficient of friction. So, in this case, you have your CV as your coefficient of velocity. Your V squared over 2G, that would be the velocity head of nozzle. So, I think itong velocity head, nakita nyo na ito sa Bernoulli's equation. Okay, but we will discuss that later on. Hindi lang muna ngayon. Okay, para mas maintindihan natin yung topic. Actually, this introduction for your continuity equation is napakadali lang. So, pinapaintindi ko lang muna kung ano yung magiging head loss natin. Okay, kasi sa mga susunod na topic, gagamit tayo ulit ng Bernoulli's equation ninyo, same sa ginagawa ninyo sa inyong fluid mechanics. So, water flows in pipes. Let us have your example number 1. Kindly have your calculators with you rather. So, para habang nagdi-discuss ako, nagkakalkyo kayo. So you have a problem here. A 0.60 meters diameter pipeline is 30 meters long, carries with 0.4 cubic meters per second of water. Compute the head loss using the following. So you have your Darcy-Weisbach, you have your Mannings, you have your Hazen-Williams. So let us have your given first. So sabi nga dito, you have your diameter that is 0.60 meters. You have your length as 30 meters. And you have your discharge as 0.4 cubic meters. So ang unit for discharge, again, that would be volume divided by your time. Okay? So let us try to solve your Darcy-Weisbach. So given that you have these formulas, you have two formulas for Darcy-Weisbach, right? So paano kaya natin kukunin yan based on our given? Gagamit ba tayo nitong first equation natin or first formula? Ano yun? First formula, I think hindi tayo makakagamit. No, it's because velocity yung given. But then again, with the use of your Q is equals to AV, pwede naman, di ba? Pwede natin makuha yung value ng head loss natin. Pero sige, hindi ko muna kayo palituhin. So let us try to use your second formula for your Darcy-Weisbach. Since you have your F given, you have your length given, you have your discharge given, and you have your diameter as given. Okay? So you have 0.0826 times 0.14 given sa problem, 0.014 times the length 30, then the discharge 0.4 squared divided by the diameter 0.60 raised to 5. 1 minute. Okay. So you have a velocity, you have your head loss as 0.071 meters. Okay? So, ano ba yung sinasabi ko kanina na pwede nyo rin gamitin itong first formula pero napaka long way niya ata, no, para gamitin. Sige, i-erase ko yung sulat natin kanina ha, para meron tayo. So, let us try to use this one. Okay, para makita nyo na pwede din siyang gamitin. Head loss is equals to FLV squared over D2G. So, yung velocity natin, yung velocity natin, kailangan muna natin siyang kunin. Di ba you have your formula Q is equals to AV. And alam nyo ano yung magiging value ng Q ninyo. That would be 0.4 and you have your area for your pipe which is 0.60. Therefore, that would be pi over 4 times 0.60 squared times V. Therefore, makukuha niyo yung value ng V and then substitute niyo sa value or sa formula ninyo sa head loss. So, pwede nyo siyang gamitin. But then for me, no, para mas safe na lang tsaka hindi kayo malito sa value, you can memorize at least one of the formula and then play along with other formulas like your Q is equals to AV. So, this is just a checking na pwede rin natin magamit yung isa pang formula. For letter B, let us use the Mannings. So, you have 0.013 as your roughness coefficient. So, in this case, no, ang gagamitin natin na formula, again, that would be in terms of your 10.29. So, usually, ako, no, ang minimerize ko lang dito, like for example, sa board exam, would be kung sa Darcy Weisbach ito, no, and then sa Mannings, ito lang talaga yung memorize ko, 10.29 n squared, q squared, d16 over 3. Ito lang yung na-memorize ko, no? So, we have given your L, given your Q, given your D. Therefore, you have this kind of formula or equation. 10.29 times 0.013 squared times 30 times 0.4 squared divided by 0.60, 16 over 3. So the answer or the head loss of this using your Mannings would be 0.127 meters. Okay, for letter C, let us use using your Hazen-Williams. So you have 10.67 L Q 1.85 divided by C raised to 1.85 D 0.4.87. So kung meron kayo nakikita sa book, no, kung mag-study kayo, ang value ng coefficient natin or ng formula ninyo sa inyong book for your Hazen-Williams is 10.64. Okay, but then again, it is now updated. Ang ginagamit sa board exam would be 10.67. So ngayon pa lang, no, I want you to practice na ang i-memorize would be 10.67. Okay? So using that formula, using this given, you have your 10.67 times 30 times 0.40 raised to 1.85 divided by 120, which is given your C as your coefficient and 0.60 as your diameter. Therefore, you have a head loss of 0.101 meters. Okay, so I'll give you 1 minute to digest the said problem. Okay, so let us continue with your second example. We have 3 examples only kasi napakadali naman ang ating topic for today. So you have here a new cast iron pipe that must carry 1.2 cubic meter per second. So at a head loss of 5 meters per kilometer. Take note, you have a head loss that is 5 meters per kilometer length of the pipe. So slope, I compute the diameter of the pipe using the following: Hazen-Williams, your Mannings, and your Darcy Weisbach. So for letter A, we'll use the Hazen Okay. Sige, let us use your Mannings na lang. Sorry for that, no, mali yung nagiging animation natin. So, you will use your Mannings given that you have your roughness coefficient of 0.012. So, since you have a head loss of 5, so alam na natin yung magiging value ninyo for your H sub F. So, that would be 5 times or equal to 10.29, 0.012 squared times 1,000. Saan nanggaling itong 1,000? That would, excuse me for that. That would be the value of your length. Di ba sabi niya, you have your head loss per kilometer length. So sa atin pa, you have your slope that it is HF over L, that is head loss per kilometer length. So since naka in meters tayo, i-convert natin yung 1 kilometer into 1,000 meters. That is why your length is equal to 1,000. Okay? So you have your velocity, you have your discharge given that you have 1.2 cubic meters per second, and you can solve for your diameter through this formula. So you have 0.0858 meters. So para hindi kayo mahirapan, no, yung shift solve pa kayo, so i-nth root nyo na lang, nth root of 16 over 3. Tama ba? So 10.29 blah 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 divided by 5. No, use your algebra na lang para hindi tayo mahirapan mag shift solve. Okay? Para isanay nyo rin yung sarili nyo. Sige nga, pakitry nga. Try nyo nga. D is equal to the 16th over 3 root of ito lahat na ito. That would be your numerator. Tapos divided by 5. Okay? Algebra. Practice yung sarili nyo na hindi kayo nag-shift solve. Okay? Next is that, dito na tayo for letter A, Hazen Williams. So you have here yung D lang yung magiging unknown. So you have 0.839 meters. Okay? Sige, paki-digest. Pause nyo na lang, no? Kapag nagsasolve pa kayo. Kasi based on formulas lang talaga tayo, guys. Wala pa tayong nangyayari. Ginets nyo lang kung paano ginamit yung mga formulas natin. Na, so for letter C, you will use your Darcy-Weisbach given that you have your coefficient of friction of 0.021. So we will use the second formula since ang given would be the value of your discharge. Okay? So you have 5 is equals to 0.8026 times 0.021 given your friction, and you have your L as 1,000, your Q as 1.2. So, kindly get the value of your D. That would be 0.870. So, kung ikakalculate nyo yan, no, kung hindi kayo mag-shift solve, so that would be D is equals to the fifth root of 0.0826 divided by 5. Itong values nito. Yan yung ilagay nyo sa numerator ninyo. So, that would be 0.870. So, kung nakikita ninyo, almost the same lang yung magiging diameter natin, di ba? Kasi parehas na naman yung pinagkunan natin ng head loss. Saan lang siya nagbabase or saan naiiba lang siya sa decimals. Kasi nga, there are some different considerations na ginawa si Hazen Williams, si Mannings, at si Darcy. Now, in terms of their coefficient. Si Darcy, no, gumamit siya ng sino yan? Si Hazen Williams, gumamit siya ng celerity. Si Mannings, gumamit siya ng roughness index. Si Darcy Weisbach, gumamit siya ng coefficient of friction. But then again, the idea or the principle of that is iisa lang rin naman. Okay, nagkaiba lang sila ng some of the considerations. So let us have your last example for this problem. So a 1 meter diameter pipe with cast iron is 845 meter long and has a head loss of 1.11 meters. So find the discharge capacity using the formulas. So you have your Mannings, you have your Darcy Weisbach, and you have your Hazen Williams. So discharge yung hinahanap natin. Ano nga yung formula ng discharge? That would be Q is equals to AV. So in this case, hindi kayo agad-agad matik, no? Na Q is equals to AV ang gagamitin niyo. Yes, meron kayong area, but then again, wala kayong velocity. Okay? So using the formulas now, let us try to solve for letter. Okay, so let us try to solve for your Darcy Weisbach. Mali na naman yung ating tawag niyan, animation. So, sige na lang. Unahin natin yung Darcy Weisbach. Or I think this is the Mannings. Okay. Just a minute. Check ko muna. Okay, okay na. So we will try to use in this problem, no, we will try to use your Q is equals to AV. Set aside ko lang muna yung paggamit muna ng mga formulas ninyo, major for head losses formulas ninyo, no, just to show you kung paano pagamitin yung Q is equals to AV natin or your discharge formula. So let us try to solve for your Mannings. So according to this, you have your Q is equals to AV. So since na pinakilala ko sa inyo yung formulas kanina, sa Mannings natin, you have a given formula for your velocity as 1 over n r 2/3 s 1 half, where your r, that would be your hydraulic radius, and your s, that would be your slope or your hydraulic slope. So your slope can be solved by your head loss divided by your length, and the hydraulic features can be solved b is equals to 4r. Okay? So in this case, ang ating ko-considered would be lahat ng perimeter ng ating circle would be covered by water. So, ibig sabihin, lahat ng ito is wetted perimeter. Okay? So, you have here for your slope, you have 1.11 as your head loss. Your length would be 845. Therefore, you have a slope of 0.00131. So, you have your diameter of 804 meters long. Diameter yan siya. And you have your head loss as 1.11. Okay? So, you have your hydraulic radius as D over 4. No? Kinonvert lang natin itong formula na ito. Divided by 4 lang. So, 4 is cancelled. So, you have R is equal to D over 4. So, taken that you have your 1 meter diameter divided by 4. So, you have an hydraulic radius of 0.25. So that would be your velocity, 1 divided by 0.013 times 0.25 raised to 2/3 times your slope, 0.00131 1 half. Therefore, you have your velocity of 1.0105 meters per second. Okay, so for your QAB, so you have pi over 4, 1 squared times 1.105. Therefore, you can get your discharge by 0.868 cubic meters per second. But then again, you can try, you can solve for your discharge formula using your formulas that I have given you earlier. Ito, pwede siya magamit. No, that would be 1.11 is equals to 10.29 times 0.013 times your length, 845 times q squared divided by 1 raised to 16 over 3. No? It will give you the same answer as 0.868. No? Shino ko lang paano gamitin natin yung q is equals to AV. Very good. For letter B, no, we will see how get the discharge pa rin using your Darcy wasteback. So in this case, you have formula, no? Second formula gawin natin since nandito na agad yung Q. So, okay. Okay, ko rin pala yung paggamit ng Q is equals to AV. So, sige na lang. Let us try to use your first formula para makita niyo paano ulit gamitin yung Q is equals to AV. But then again, if wise kayo, no, pwede na, matik na ito yung gagamitin niyo. So you have your 0.11 times is equal to 0.021 times 845 times v squared divided by 1 to 9.81. So you will get the value of your velocity as 1.108 meters per second. So we will use your discharge formula as Q is equals to AV. So you can get the value of your discharge as 0.870 cubic meters per second. So let us try to check if totoo ba talaga yung sinasabi ko na parehas na yung pagkuha natin gamit ang QAV natin whereas compared dito sa second formula. Sa second formula ninyo. So you have a head loss of 1.11 is equals to 0.0826, 0.021, 845 q squared divided by 5. So using your algebra, no, para hindi na kayo mag-shape solve. So you'll be getting or you will be having a ito, 0.111, the square root of 0.111. Try nga natin calculate kung tama ba yung aking pag-derive. So you will have, sige, solve natin sabay. So you have 1.11 divided by 0.0826 times 0.021 times 845. Yes, you will get the same answer. No? So you will have 0.870 cubic meters per second. Okay. Okay, that is for today. So if you really did watch the presentation or my presentation for today, you notice that I didn't answer for letter C. So if you did really watch the video, so kindly answer letter C and then comment your answer sa ating comment box, charot, here on YouTube. So you will be enjoying plus 2 points in our next quiz. Okay, if you really did watch the video. So kindly answer for letter C, and if you have a correct answer, matik that you will have a plus 2 sa inyong quiz on our next quiz. Okay? So lucky you if you really did watch the video. Okay? So, yun yung magiging basehan ko kapag kung pinanood ba talaga ng buo. So, kung if ever wala mang mag-comment, no, sa chat box, mag-comment in this video talaga, ibig sabihin, walang ano ba yan? Walang mag-e-enjoy ng plus 2 sa quiz. Malay mo, magbagong isip ko, plus 2 sa quiz or plus 2 sa exam. Tama? So, if you really watch this video, kindly wag lang maingay, no? Let your classmates watch the whole video talaga. Okay? Sige, yan lang. So, thank you everyone. So, I hope you learned something. If you have any concern or clarification about our topic, so kindly chat na lang rin sa GC natin. Okay? So, thank you everyone and God bless.